Okay, here we're given a very simple issue with complex zeros. Notice the degree is 3, and one of the zeros that's given is a real number, and the other one is 3 minus I. If we apply our conjugate pair rule, we know that the other zero, or the third zero, is just the conjugate of that. Okay, so we have a degree of 3, and our total number of complex zeros need to equal the degree. Alright, so in this next example, we're going to use this idea with the complex zeros and conjugate pairs to form a polynomial with real coefficients, given these complex zeros. As you see here, we're given one complex zero, 3 plus 2i, and then 4 with a multiplicity of 2. And we're told that the degree is 4. As noted above, the other remaining zero is the conjugates, 3 minus 2i. So we have all 4 zeros that equal the degree of the polynomial. Now that we have the zeros, we are going to take each one of those zeros and create an equation x equals each one of these zeros. Notice that x equals 4 occurs twice. That's based on the multiplicity that was given. When we go through this, we want to treat each one of these complex numbers as just a number itself. So we're not going to break up this number as if it were an expression. We're just going to algebraically get that equation to equal 0. Here you can see that we're going to clean this up and then look at the rest of these real zeros, and that's pretty standard operation right there, where you get all of the equations equal to 0. Now we're going to take those 4 factors and we're going to create our polynomial in factored form. Here it is completed after we put everything together. The next step is going to be, when we do the distributive property, we have to be very careful when we get into the part with the red, where the red brackets are. So with the x minus 4 times the x minus 4, I went ahead and fooled that out, and that gives you the trinomial there in the beginning. Next, we continue to do the distributive property here. Be very careful when you get to this point right here and you start distributing things to these complex numbers. Don't break up the number yet. That will take care of itself shortly. But as you go through, you see we distribute accordingly, just like we would traditionally with anything else we're comfortable with. Alright, so here we go. We're distributing everything here, and as you can see, as we distribute the negative 3, or the negative x, it breaks up these complex numbers, and we get some crazy looking numbers there, the plus 2i, 2xi, and the minus 2xi. The next part of this is going to be where we FOIL out the 3 plus 2i and the 3 minus 2i. And we just approach that similarly. Now remember, the I squared is equal to negative 1, so that's going to have an effect on the end result here. The 2xi terms cancel each other out, and so now we're just going to clean this up. Combining like terms where appropriate, and that's what we're left with. We're still not done. We have to go through and we have to distribute the first trinomial to the second trinomial. So you have 3 terms in the first trinomial, 3 terms in the second trinomial. So just a little trick here, you're going to end up with 9 total terms after you have done the distributive property. Then we would go into and combine like terms. So we're just going to let this play out, and you can see the distribution taking place. Pay attention to your rules of exponents. And if you'll notice right here, when we get to the end of it and we pause it, count them up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. Now we just need to go through and combine like terms and wrap this up. So you want to look for all of your x cubed terms, then all of your x squared terms, any x terms, and then your constant shows up at the end. Thanks for watching, and I hope this helps you out a little bit dealing with complex numbers and forming these polynomials based on those zeros.